Okay, so good morning everyone. So we'll talk about the spectral acceleration maps of the Philippines and its application sa ating code. Okay? Right now, ang ating governing code is NSCP 2015. Pero topic ko lang yung magaan na file 2010. Konti lang naman yung difference. Okay? This is patterned after UBC 97. Pattern after UBC 97. So, yung date, no? UBC 97. Ganun na ka-outdated. So from the UBC 97, ang main requirement is yung zoning. No? Diba meron tayong Philippine map, tapos nakalagay yung kung anong zone yung location ng project mo. No? So, doon yung nangyayari sa kanya. Yan. Something like that, no? Tapos, generally, ito, zone 4. Z equals 4, no? And that corresponds to 0.4 G, no, na PGA. Corresponds to 0.4 G PGA. Now, ang current na prevailing code sa US, no? Why do I mention US? Because we patterned our code sa Amerika. No? That's why yung UBC 97, it's previously used sa Amerika. No? Ngayon, ang prevailing na code sa kanila is IBC. IBC. Hold on, IBC. Then yung parang committee na na nagdi-dictate ng earthquake load, no? Mga dead load, live load, ganyan, is ASCE. ASCE. So, I think American Society, no, of Civil Engineers, no? So ang sa atin sa Philippines, no, kumbaga ang IBC sa atin yung National Building Code, no? Yun yung National Building Code, then naka-attach sa National Building Code yung bawat code ng mga discipline. So sa structural, NSCP, no? Sa sa Fire Pro, Fire Code of the Philippines, mga ganon. Okay? So with regards to civil design, ASCE. Okay? Next. Now, si IBC and sa ASCE 710, for the earthquake loading, they use the spectral acceleration map. Spectral acceleration map. Yan. Okay? Which is similar to this. Okay, so ito namang spectral acceleration map ng Philippines is done, no, by the DOSTP vaults. So, syempre hindi si ASEP, no? Kasi sa DOSTP vaults, nandiyan yung mga geologies, no, seismologies. Yan. Okay. Then it shows yung mga spectral acceleration, no, per location. Give you an idea, ito siya. Okay? Parang nakakontour no? Nakakontour siya. No? Instead of elevation, spectral acceleration yung quantity. Okay? Then that's why uh, knowing that you will be required, to use this map in the future, no? I'm saying in the future kasi hindi pa to yung governing code natin, no? Parang nire-ready ko lang kayo, no, in case na mag-transition tayo sa IBC, no? Okay? So, we may say, no, uh, the next code, no, NSCP, no, question mark, no, might refer to this uh, publication sa US, wherein in the earthquake code or seismic code, they are using the spectral acceleration map and not this type of map na by zoning. Okay? May kita nyo naman no? What are the what are the differences, major difference. For example, yung buong Philippines or 90% of the Philippines parang isang naka-uniform Z equals 4, no? Z equals 4. While sa spectral acceleration map, iba-iba, right? Iba-iba. Medyo specific na yung value. Yan yung mga major difference. Therefore, there's a chance na mas maliit yung base share mo, no? It's either mas maliit or mas malaki, no? Compared to the UBC 97 seismic code. Yan. Yun yung, that's one of the difference. Okay? Kaya, sa plates nyo, include ko to sa plates nyo, no? Di ba, meron kayong previously, last sem, meron kayong base share using UBC 97. So, what about using this IBC? No? Baga, i-update nyo yung base share nyo, no? Alamin nyo yung location ng project nyo. So, for example, dito San Fernando, ito yung gagamitin yung spectral acceleration, 1.1. Okay? Next. And that's why, no? That's why tinuro ko muna sa inyo yung response spectra. No? Because eto, no? Ito yung ginawa natin nakaraan, no? You were able to get this curve, no? The acceleration response spectra. And I said, itong acceleration nito is actually the spectral acceleration. No? So sinabi nga natin, no? For example, this is itong data na to ay 0.5 seconds. No? So 0.5 seconds is roughly 5-story building. So parang COE building, no? So kung nagkaroon and remember, yung response spectra na yan for El Centro ground motion, yan, that has a PGA of 0.32 G. Ganyan kataas yung PGA niya. And by looking at this or comparing, no, sa ilalim, no, ng COE building, for example, umabot ng 0.32 G yung acceleration. Then, at the top of COE building, no, sa 5th floor, the acceleration or the spectral acceleration at the top might reach 1.1 G. Mas mataas pa, no? Okay. While for the 20-story building, no, 0.32 G, no, sa taas, sa ground, pero yung nararamdaman sa taas is just 0.2 G. Ito, 0.191. Mas maliit di hamak. Okay? So you can imagine, no, yung application niya sa IBC. Okay? So which means generally low-rise building will experience large acceleration while high-rise building very low acceleration. Okay? But very large displacement. Okay? So, balik tayo dito. No. Now, this is a spectral acceleration map of the Philippines, uh, SA for a 0.2 seconds structure. And roughly, what is 0.2 seconds? How many floors? That's two-story. No? Two-story building, two-story structure. A typical na residential. No? And the mean recurrence interval is 2,475. Sobrang ano, no? Sobrang laki nung return period niya. 2,000, roughly 2,500 years. No? Eh, pag nagpatayo ka ng bahay, no, do you think aabot yun ng 2,500 years? So, hindi, no? Uh, hindi yan naabot, no? And most likely, no, magde-degrade yan for the first uh, 50 years, no? Sobrang ano na yung, lalilit na yung FC prime ng concrete mo, so on and so forth, no? So, this is a MCE level. No? So, why do I say MCE level? What is the MCE level? Definition yan dito. Yan. Definition of terms. And an earthquake severity estimated to occur at least once in 2,475 years. Sulat ko. Nag-ano to? 2,475 or yan ko na lang ha. 2,500 year return period. Yan. Okay? That's the MCE. Or in terms of probability, 2% of being exceeded in 50 years. So 2% 50 years. Okay? And anong shortcut ko dyan? Dapat pala pag nagtatanong ako, ano eh, tinanong ko dito kahapon, walang makasagot eh. Kaya iba, masarap talaga pag nagpapa-exam eh, para natatandaan, no? So since PCS1, no, mini-mention ko yung shortcut diyan, no? How do you roughly compute? No? It's basically 50 divided by kung ano yung probability, 0.02. You will get 2,500. Double check mo. 0.02. Yeah, 2,500. Okay? That's the MCE level. Now, proceed kayo tayo sa NACP. Ano ba yung ginagamit natin sa NACP? Ito, the Design Basis Ground Motion. Okay? Or DBE. Sulat ko. Ano naman ang definition ni DBE? Is the ground motion that has 10% chance of being exceeded in 50 years. Yan, sulat natin. 10% chance in 50 years. Using the shortcut 50 divided by 0.1. Okay? And you will get 500 years. Let you okay? So, kapag naging engineer na kayo, no, pumirma kayo ng structure, pumirma kayo ng building permit, you are designing for a 500-year return period. Yan yung design basis earthquake. Okay, 10% chance of being exceeded in 50 years. Okay? Or once every 500 years, the earthquake. Okay? And that is nga 0.4G, no? Okay? Now, yung binigay na mapa sa atin is MCE, no? MCE. So that's 2,500 year return period. That's why may procedure, no, to no to obtain your base share from a map showing an MCE, maximum considered earthquake. Okay, kasi syempre alam naman natin mga geologists, yung mga geological time na pinag-uusapan sa kanila, sobrang lalaki ng interval. Okay? So, therefore, kaya itong map na to, yan, yan, yung mga spectral acceleration dito, yan, is good for a return period 2,500 years. No? Sa ganun kalaki. Ayan. Okay. So, next. So, you will see a spectral acceleration map of the Philippines, 0.2 seconds or 2-story. And take note, on rock site. Rock. No, sa bedrock. Okay, on rock site. 2,500 year. Okay? Kaya, ito, tingnan natin to. Pag-aralan natin. Remember, earthquake happens sa bedrock. No? Na-amplify lang yan, no? Papunta sa soft soil. No? Yan. Like to see this. So this is the uh, yan, input in determining bedrock response spectrum and ground surface, assisted design phase of civil engineering structures to be built on site. Ayan, ito siya. Titigan nyo yung response spectra. This is already the response spectra. No? Okay. So, medyo internalize nyo, no? Ano yung pagkakaiba sa San Mateo, sa Intramuros, no? Sino pinaka maliit yung acceleration, sino naman yung pinakamalaki. No? Titigan nyo saglit. Okay, yun nga pala, no? Ulitin natin, no? For the purpose of recording, no? Again, no? May kita nyo dito, ang pinakamalaki is the, I think, Marikina, and yung black is maybe Pasig to, no? And as you remember, no? Marikina, Pasig, magkakadikit, no? Sige, try natin i-ano, ipakita yung mapa. Yan. So, according here, no, we have Marikina, Pasig. So, Marikina, Pasig, ito siya. Yan, Marikina, yung West Valley Fault. Something like, ano eh, parang paganyan, no? Yan. Cross ng Makati, yan, BGC, and Market, something like that. So, and you notice, yung lugar na yan, matitigas ang lupa dyan. Matitigas yung mga lupa dyan, no? Punta ka sa C5, may makita kang ano eh, no? Very slope na bato talaga, no? So meaning, nandun yung bedrock eh, no? Parang nagpo-protrude na doon yung bedrock. BGC, matigas din ang lupa doon. Okay? So ito yung spectral acceleration nila. Okay? Let's say Intramuros, no? Layo. Oops. Ito naman si Intramuros, dito. So you will observe, no, that etong mga to, generally, itong mga lugar na yan, bahain yung mga yan. So, nandyan yung mga soft soil. Okay, soft soil. So, you can imagine, so ito, bedrock tong mga to, bedrock, then, dahil soft soil to, meaning the bedrock will go deeper. Kaya kung, kumbaga, I'll do a cross-section profile ng ng soil test dyan, for example, will look something like this. Ganyan siguro. Yeah. Okay? Uh, then, ito, din natin ito. Parang ganyan, no? So, yan yung mga soft soil. Okay? Yan, parang ganyan. So, say dito is Marikina or QC. Then ito, Intramuros. Or even Manila. Dito, sa TUP Manila. Okay? And these are the bedrock. Bedrock. Okay? So, sabi dito, yung ano nito, yung spectral acceleration, sabi natin, sketch ko 1.2, no? So, kung may response spectra ko dito, vision na to, this, ganyan. So, this is 1.2. That while sa Marikina, it will be 1.9. Ito is natin ganyan, 1.9. Okay? Yan. Okay? Dead, no? Kasi bedrock, no? I'm consistent dapat sa bedrock. Something like that, no? Okay? Hindi ko sinasabing walang soft soil sa Marikina, no? Meron din kasi lalo na yung portion ng yung binaha ng Ondoy, no? Yung mga portion doon, no? Okay? But generally kasi um, na nagpo-protrude na yung mga ano doon eh, mga bato doon. Makikita na. No? Okay, next. Uh, so yun yung ano no, yung concept nun, no? And sige, to cut the story short, no? This is in Bedrock, no? But we know that when earthquake happens here, ganyan, yung shaking, no? Pagdating mo sa subsoil, mag-amplify yan. Yan, mag-amplify yan. So, so you have another response spectra dito sa taas, no? You will have another response spectra here due to the uh, soft soil, no? Iba na yung response mo dyan. Okay? So, kumbaga, para maging uniform yung map, no? Normalize siya sa bedrock, no? Ganun yung ginawa ng mga geologists or seismologists sa pivots, no? Ngayon, tayo as a structural engineer, we will devise a way to amplify this this response spectra according sa site, according sa softness, hardness ng soil mo above the bedrock. Okay? That's why nandun yung ah ah doon papasok yung code natin, no? As a, of course, as dictated by ASCE, no? Kasi doon natin pina-pattern yung ating NSCP. Okay? From American ano, experts, no? Yung mga experts from America, no? Okay? Because again, because uh, parang ano no by the features of the West Valley Fault, no, parang they concluded na halos the same naman siya sa San Andreas Fault line sa California. That's why it may be applicable. Okay, okay. Next is so siguro a quick ano no a quick checking, no. For example, again sa sa Intramuros, no, here. Yan. So the distance to the West Valley Fault is 10.5 kilometers. No? The PGA is 0.522. Ganun kalaki. No? Sir, 0.4 lang sinasabi niyo. Remember, this is MCE. no? MCE yan, no? 2,500 year return period. Yan. Kaya malaki talaga sa 0.4 yan, no? Okay? Next, spectral acceleration ng 0.2. Again, what's 0.2? Two-story building, no? Two-story residential structure. The spectral acceleration is 1.21 G. Okay? Which is consistent dito. 1.2. 1.2. But in Bedrock. Nasa Bedrock siya, nasa Bedrock. Next. Spectral acceleration of 0.5 structure. 0.5, roughly 5-story, parang koi building, is only 0.8. Spectral acceleration ng 8-story is 0.5. Generally, pababa na yan, no? 10-story, 0.481, 20-story, 0.25. For a 2,500 year return period earthquake. Okay? Yun yung pinaka niya. Ayan, even yung dumping niya, no? So, people's publication, 5% din yung inassume niya. No? Which I said, even STAAD software, ETAB software are using as a default value, no? In most structures, no? Lalo na sa concrete. Okay? Distribution of active faults. Kita nyo, daming earthquakes sa Philippines, no? And then, it's very obvious, no? But pagdating sa Palawan and Sulu, Tawi-Tawi, very minimal lang yung mga records that an earthquake, no? A lot of earthquake had occurred, no? Very konti, no? Then, ito naman, yun nga, parang overview for the whole Philippines, no? Ito, yan. And as you see, ito, blue, no? Meaning, maliit yung spectral acceleration niya. No? Ito, di ba, ang red is 1.61 to 3 to 3G. Sobrang lakas, no? Sobrang taas, no? Yung mga reds, no? 3G, aabot. Pero yung mga blue, sky blue, less than 1.1. And shows here, yun nga, yung mga bandang Palawan, and Sulu, Tawi-Tawi, Holo. Yan. So, okay. Titigan nyo nga saglit para maka-idea kayo. Gaano ka pula, no? Kita nyo, yung Mindanao, sobrang pula talaga. So, ang lakas or ang taas ng hazard talaga sa Mindanao. No? Pulang-pula yung buong Mindanao. No? Okay? Again, papansin nyo, no? Sir, yung palang sa Luzon, hindi pula lahat. Like ito, no? San Fernando, Pampanga. Meaning, 1.1G, at meaning, siya yung minimum, no? Na makikita mong may spectral acceleration. Sabi, pinakamababa among the colors, no? But remember, no? Bedrock ang pinag-uusapan. Bedrock, no? So, although say for example itong San Fernando, Pampanga, although 1.1 G lang yung spectral acceleration niya compared sa ito 2.8 sa La Trinidad, Benguet, no? Yan, although 1.1 G lang siya, but remember yung lupa diyan, 'di ba? Malambot, no? And in fact, may lahar pa, no? So pag nag-shake yung bedrock mo, although 1.1 G lang yung spectral acceleration, because of the soft soil above, mag-amplify pa. Okay? Mag-amplify. So, hindi mo pwedeng sabihin na no? O yan, tingnan mo sa map, no? Ano lang ako, among the colors, kami yung pinakamaliit. Hindi ganun no? Hindi mo pwedeng sabihin ganun. Because it's only for bedrock. Okay? Sige, so, and also, no, kung may 0.2 seconds, meron ding 1 second. 1 second is 10-story building, no? Baga, kung merong what do you call this? 10-story building sa Palayan City, Nueva Ecija to, no? I think 1.1 G yung may experience in 10-story. If it's in the Bedrock. Okay? Next is, ayan. So, ito na yung by region na. By region. Bawa, ito. Ito. Marikina, you will see pulang-pula, no? 1.7 G. Again, 0.2 seconds. 2-story building subjected to a 2,500 return period earthquake. Okay? 1.7 G. Sabihin mo, no? Ang liit lang pala sa amin sa Valenzuela, no? Kumpara sa Marikina. Right? But again, Bedrock ang pinag-uusapan. Nakakita na ako ng soil test sa Valenzuela around 15 meters yata. Ganun, no? 15 meters below, no? Nandun pa yung Bedrock. Okay? Ganun. 10 to 15 meters, ibig sabihin, soft soil siya. Okay? Kaya nga, when you work, no? Interesting, no? Interesting magbasa ng mga soil test para magka-idea kayo how stiff ang soil sa bawat location, no? Anong governing bearing capacity. Okay? Okay, so next is so that's for 0.2 seconds or 2-story. Ito naman 1 second or 10-story. May 10-story sa Valenzuela, no? The spectral acceleration can reach 0.5. Okay? So bakit ganun? No? Bakit ganun yung presentation? 0.2 and 1 second. No? Because yan yung sinusunod sa IBC. Yan yung sinusunod sa IBC. So ito yung same spreadsheet na ginamit natin last time. No? So ngayon, we will now proceed sa ASCE 710. Ito, ASCE 710. You will see, nag-generate din siya ng response spectra. Okay? We will compare ano ang response spectra ng ASCE versus UBC. And UBC, nagawa na natin to, no? Last time, no? So, I think nagawa natin, no? So, we'll compare that, no? With our ASCE, with the IBC. Okay? Sige. So, next. Ano bang magandang example? For example, sige, Koi Building dito sa Manila, no? Okay. But in terms of response spectra, gaya ng napag-usapan natin last time, it depends, hindi sa height eh, no? 'Di ba? Sa vision na yan makaka-affect, no? Kasi nga height dictates the period eh, no? So, doon muna tayo sa response spectra, no? So, yan, ito yung pinakauna. What is the S sub S, no? Or the short period 0.2 second spectral response acceleration, no? Okay. Huwag niyo napansinin yung figure na yan, no? Kasi pang US yan, no? Tayo sa S of S, 0.2 seconds. Tayo. 1 second yan. Tayo sa kabila. 0.2 seconds. Manila, you will see, yan, dito sa TUP dito. Kasi pier to eh. So, roughly here. Siguro. Yan siguro. So, we are between 1.3 and 1.4. 1.3 and 1.4.